So good morning, everyone. It's good to see you again. And I guess so far we talked about databases, we talked about Java, we talked about web programming. Now it's time to go ahead, talk a little, regarding data structures, probably algorithms, and so on. And that is the reason we are here, right? So let's just get started with data structure, what data structure is, or before that, what all we need to know before we start with the data structure, what all we are going to see in a module, and then we will actually get started with the topic. So the very first thing, what is the prerequisite of the module? I guess I already typed it on your WhatsApp group. What is prerequisite of module is Java programming language. So I'm very sure you people had extensive work onto the Java, and you should be very comfortable. Probably this list I have already shared with you. Something that I said that you may not much need into the when it comes down to the data structure algorithm is like inheritance, polymorphism, or this kind of concept. So we need the fundamental of OOP concepts. We need the mainly language fundamental in the sense variables, if else, loops, switch cases, these kind of stuff we need it often apart from the other ones, right? So I'm very sure you must be knowing, as I said, that this particular module will be like more or less the practical oriented. It's like we'll be having more focus on actually doing the things than just knowing the concepts. And the language of doing, probably for your batch, is like Java programming language. So it doesn't make any difference, because when it comes down to the data structure, so it is language agnostic, we said. So whether you are done in C++, whether you are done in Java, whether you want to do it in like Python, whether you want to done like any other language, it is absolutely fine. The data structures always remain same. Yesterday someone asked me the question, and that is the reason I believe that I should also answer that, just for the better clarity of like everyone. There was a question that when we talk about Java, so Java has got something like a built-in collections. You go to the Python, or Python has got its own collections. You go to the C++, it has got like a STL. You go to the C sharp, it has also got its own data structures. So the question is, when the programming language already have kind of a linked list available, when the programming language already have got arrays available, a programming language already have got a library where the stacks and queues, everything is available, why we are learning it once again, or why data structure is kind of a separate module? If you ask me, there are like a couple of reasons. A reason number one is, the very first reason, I would say that the very first reason is like your thinking abilities. Your thinking abilities. The data structure module is one, probably where we consider few really small problems and few really big problems. A small problem could be like add a node into the linked list, or probably a kind of a big problem that find the what is the shortest path between 2 points in a city, something like that. So given a problem statement, how do you think upon it? So what are the major mechanisms, or what are the major thought processes behind giving any problem statement, like a thinking in the algorithmic way of thinking, like a first thing. The second good reason is that a lot of time people keep complaining that, so we are not too good at coding. I always believe that data structure is like one of the module where you can be really good at coding, where you understand the algorithms. So you spend a little time in understanding algorithms. You spend a little time understanding algorithms, what algorithm is, how algorithm is, or like how it is going to solve. And then ideally, then you implement that algorithm into your own way, into your own way. So people who always consider that, sir, I'm a bit weak into the programming, this is always ideal. Like for example, you learn a selection sort. So you don't focus onto the code of a selection sort. You first focus onto the kind of a algorithm of a selection sort. You focus on algorithm of a selection sort. You understand its paperwork. You do the paperwork on your own. You make yourself more comfortable. And as you are comfortable on paper that I understood how algorithm is working, then you think of how do I convert it into a programming language. So programming language again, now programming language of your choice. So whichever language that you find it good, so you can, right? The third thing, fourth thing, probably why data structures are there into your syllabus. The one more reason, probably I would say that it is, wait for a minute. It is interviews, because it is very common that in an interview you have got like a questions on like linked list, questions on like a sorting, questions on a searching, and then again you have got question. So why these people are asking us? Are these people writing all the way, down the line, ये एक साल दो साल कंपनी में सिर्फ लिंक लिस्ट लिखाते हैं क्या? टू बी फ्रैंक, कंपनी में जाने के बाद में हम लोग कभी नहीं लिखते. सो कंपनी में जाने के बाद में what we actually take, what we actually use is probably the ready-made linked list. The ready-made linked list class is there in Java. A ready-made list class is there into the C sharp, into the C++. So things are ready-made available. But again, why in interviews we are mainly focusing onto the data structure? Reason is again same, that interviewer want to know that can you think logically? Can you think like whatever problem statement that you have got, are you able to convert it in an algorithm, in a flowchart? And then if you are able to convert an algorithm, are you capable of converting it further into the code? Is it possible for you? Now this is what again interviewer always ask you. So when it comes down to the interview, and probably interviewer is asking you, okay, go ahead, write a quick sort. If any person has written a quick sort directly in the sense without any kind of paperwork, the likely chances are that that person is out of interview. तो बोले sir, we are correct. Yes, you are correct, but the interviewer is not interested in knowing that okay whether you have mugged up quicksort or not. He is interested in what was your thought process behind that entire story. So how exactly you thought of, how exactly you are taken like a pivot, then what kind of paperwork that you are done, what logic that you are put, and then are you able to convert that logic into a piece of code. So anyone who is saying that okay this is like algorithm, and this algorithm I have just by hearted and I have just written there are likely chances that in interviews you fail. So I'm saying that what we need to take care, what we need to focus on is obviously we need to understand given a problem. So first thing, we need to think. Second thing, we need to put it in like a algorithmic way, that how we can try to convert it into a computer algorithm, and then from the algorithm how we can convert into the code. So in my case, in my opinion, these all 3 points are important, and that is the reason we are learning data structures. So data structures we are writing is not for competing the Java framework. तो सर जावा का कलेक्शन फ्रेमवर्क है सर, मैं उनसे अच्छा कलेक्शन लिखता हूँ. नो, डोंट ट्राई टू डू लाइक दैट. सो हम लोग यहाँ पर उनके साथ कंपटीशन करने के लिए नहीं है. वी आर हेयर टू अंडरस्टैंड इट, right? And are we able to write it on our own? That is something we are looking for. I guess that gives you clarity why we are learning this Flow module, even though Java has got built-in collections or any other programming language has got built-in collections. Okay, what all we are planning to learn into this blog course is definitely we talk about some conceptual stuff like time and space complexity. Yes, definitely. We talk about linear search and binary search kind of mechanism. We talk about like recursion. We said recursion is something that you must be already knowing, but still, we will again go through the recursion. The reason is bit different, because this recursion understanding you also need it for one of some advanced stuff. So we will have a quick recap of what is recursion, and then how we can use recursion for solving certain kind of problems. Then we will talk about like basic sorting algorithm like selection sort, bubble sort, insertion sort or stuff. We will talk about the linked list, linked list concepts, linked list implementation. We will talk about the queues, we will talk about the stacks, and even the applications of queues and stacks. We will talk about. Then we need to talk about trees, that what basically the binary search tree is or how it can be implemented, and then more or less conceptual stuff. We need to also discuss what is heap or probably what is heap sort. But obviously, heap sort is kind of one of the advanced sorting algorithm. There are like other sorting, advanced sorting algorithms are also available, like you say quick sort or merge sort. Yes, we will talk about that. We also have got something called a hashing, hash table. I'm very sure in Java you already use hash map. But even though Java gives you built-in hash map, I want to learn, okay, how this hash map is like internally implemented. What is the technique behind it? What is the logic behind it? Can we write our own hash maps? Yes, that is what hashing or hash table concept. And finally, we will go onto something like graph theory, and not only graph theory, even graph implementation. Now you ask the question, how many days it needs? To be frank, I just recently we completed for the February batch. You might be knowing if your friends are there, and it took around 8 days to complete. Obviously, I cannot teach it at that short span, but then we will. My plan is that we will go for nearby 10 days, 10 working days, where we will talk about all these codes and algorithms. But then apart from that, something more, as I said, that it is about thinking abilities also. So there are two, three very common techniques of solving the problems. The problem solving techniques. What do you call it as a problem solving techniques? As I said that we will look more practically, but still you have to know what these techniques are. So there are two, three most popular techniques are there. The first technique, divide and conquer. I'm very sure you must have heard of this technique. And this technique, the divide and conquer technique, is something you call it as like a recursion. Yes, it goes around. The second technique I can talk about is probably greedy approach or greedy algorithms of solving the problem. And the third one is solved as a dynamic programming. And yes, we will be focusing onto all those as well. There are several, yes, brute force is there, or like many other are there. Uh, Something, the most popular, the most straightforward algorithms, most of the algorithms, they fall in this kind of category. So yes, apart from those, more of practical stuff, these are the conceptual ideas that we want to get. And obviously not only conceptual ideas, probably conceptual idea is like hardly for one slide, but after that we need to implement in a program, and then we need to visualize, oh, what exactly it means. Correct? So what I was saying is that so nearby 10 days it will take, where we can go through this flow module and we can try to learn all these concepts. As you must be knowing, and अभी तक आपको अंदाजा आ गया होगा. So as far as exams or like evaluations are concerned, I guess by this time you know the pattern. The very first thing is your theory exam, which is expected to conduct at the end of the course. What we usually call it is CDAC course end exam, right? And you are expecting it somewhere into the March, right? The second one is your lab exam, again like a 40 marks, with a combination of like hacker earth or like some sort of problem. What is that, file upload kind of problems? But I believe that at this time there will be most of them, it will like a hacker earth based kind of questions. So 40 marks, and you can expect the exam to be on nearby 10th of January. You can mark a date. So like instead of like asking every day, sir wo exam kab hoga and when I should start preparing, so better you mark a date. I guess it is 10th of January, somewhere I guess it is Sunday nearby. So mostly it is planned like that. And a third one is probably obviously the internal exams. There will be some of the assignments check, as well as there will like a quizzes and etc etc. So this like again that will be like somewhere at the end of the module. You can expect it to be like 11th or 12th January nearby. So I told you that this will be something, our module plan. This will be kind of evaluation, what all we are supposed to learn. I guess it is enough of introduction, and we should really get started to understand what data structure is basically. Obviously, I have not written a very small concept that what is data structure, etc., etc. But yes, they will follow all the way, and we will begin right from a very fundamental question: what do you mean by data structure? Yeah, getting back. So, what is data structure? If you ask me in a very simple language, I would say that data structure is structure of data. What? Data structure is a structure of data. This is probably, kind of very much what I can say. This is kind of very much very diplomatic kind of definition where you simply say that data structure is a structure of data. But exactly what you want to talk about as a data structure? So basically, what I want to talk about data structure is that when I say structure of data, it mainly covers two things. The number one, how the data is organized in memory, how the data is organized in memory, how the data is arranged in memory. So like kind of contiguous memory hai, or kind of linked list kind of node, each node pointing to another node hai, or something different, something that it is organizing data in memory. And the secondly, I can say that processing the data. Secondly, like a processing the data, whatever data is available, you just do not want to see the data. You want to do certain operations on that particular data. So again, how the different operations to be performed onto that particular data. So usually when you say that I'm learning data structure and algorithm module, you are trying to focus on how a particular data can be arranged in memory, number one, and number two, how the execution can be done on it. Again, in both the lines, I should be using a word, something called as efficiently. So efficiently, I'm talking about efficient storage as well as efficient processing of the data. So, sir, what all different data structures that we have got, or different data structures that we have got? So we can start talking about. There are, again, this is not really the bookish one, but I would say that this is a rough division. You can say there are certain data structures which comes out to be like very normal, very common, and usually by default available in most of the programming languages. However, there are certain data structures which are, when I say advanced, they are quite application specific, and most of the time you need to build them by yourself. Getting back, so you talk about, we have got like an array. So you ask the question, so array is a data structure. So we have learned array in almost every language. Yes, you learn array in every language, but trust me, even array is a data structure where you say that the data is stored in a contiguous location. So array itself is a fundamental data structure, and you will not believe, probably it is one of the most commonly used data structure, which you have already used into almost every language that you have done. But you never know that, oh, it is a data structure, right? Going ahead, you talk about like a linked list, another very popular kind of data structure that we deal with. Then we talk about stack, we talk about queues. These are, we said that it is like a utility data structures. Utility data structure meaning by not for saving the data, but to process the data. So they are not for the storage, they are for the processing, and the intermediate data will be saved into that. So like a stacks and queues. You continue further. We have got like a trees bit, as I said, it comes down to the little advanced data structure. So we have got like a trees are for the optimized searching, that is like a main goal of a trees, but there are other advantages as well. Some more specialization, I can say that it is a heap. After you talk about tree, you have to talk about a heap, and then we can also go ahead and talk about a graph. Now these are the data structures which are not available into most of the programming languages. I do not say all of the programming languages, but I say that most of the programming languages, you may not see a ready-made tree is available, or ready-made graph is available. Yes, heap is available in at least few languages that I know, like Java, but I'm very sure you may not have worked on that. Like for example, Java has got a concept called a priority queue. The priority queue implementation of a queue that internally uses kind of a heap. So, but that is the reason I just consider it as like advanced data structure. And this data structure usually you need to build it by yourself. So with this, but what basically the data structure is, what exactly we need to focus when we talk about data structure. So there is a word that always people use saying that data structure is ADT. What is ADT? ADT, is it advanced or something like that? No, no, not at all advanced. ADT stands for abstract data types. I'm very sure you come across the word abstraction during your OOP concepts. So abstraction, yes, abstract data type. What is abstract data type? Where in OOP there is like a foundation principle. You always say that what is there inside the object, what is there inside the object, what kind of data is inside the object, you do not bother. But what do you bother? You bother what all operations that you are providing. So you are not worried about what is hidden behind it. You are always worried about what interface is given. So when you talk about like a watch, you talk about a watch, you do not bother what kind of machine is used, what kind of chip is used internally or whatever. I said that it hardly matters. What I'm worrying a lot is how do I how do I use that watch? How do I see the time? How do I change the time? Now these are the kind of stuff that we are trying to focus on. Correct? So when it come down to the like external implementation, or when it come down to using data structures, we always say that it is abstract data type. And that is what you people have done in Java. So in Java, you always say that there is an array list. Now there is an array list, there is a linked list, there is a vector, and you found that almost all have got all kind of functionalities. They are giving you kind of similar kind of output. So you always say that key there are certain functions that I need to execute. So I need to add a data, or probably I need to remove a data, or I want to check whether the data is available, kind of contains method. And there is a method to search where is the index of method. So in Java collection, they have given you the built-in methods. So you do not bother about how it is created internally. Probably we never seen that whether they are using a kind of a node structure, whether they are using a kind of a array structure, whether they are using something different. Who cares? What is important? Important is that what add method does, what remove method does, what contains method does, what list iterator does, what index of does. So we should be knowing which all parameters to pass and what value, what results to collect. That's it. This is what all we look for. We never bother about how the implementation is done by the Java people. And this is something I'm saying is the abstract data type. So when it comes down to the data structure, you always say that it is abstract data structure. We are more concerned about the operations done on that than we are like concerned about how it is implemented behind the scene. तो वो एक आध एग्जाम्पल हो जाए. Yes, absolutely. Like for example, you talk about array as an abstract data structure. When I say array as abstract data structure, which all operation the array should have? Array के अंदर कौन कौन से operations होने चाहिए? I believe that array should have only two major operations. Only two major operations. One, I said that get element at a index. Get element at a index. And second thing is like a set element at a index. These are, I would say, kind of a primary operations that array data structure should provide. The basic minimal operations. Obviously, now using these operations on the top of it, there can be even advanced operations. The advanced operations like searching in an array, binary searching in an array, sorting of array. Correct? These are more or less kind of advanced operations on the top of array, but the very basic level operations are very simple: getting an element at a given index and setting an element at a given index. So you say that array is kind of abstract data structure which enables you for something called as a random access. Something called as a random access. So you want to access nth element directly, and that is what all you look for. Now you go ahead, you talk about another data structure. Let's say probably you must have heard of stack as an abstract data structure. Stack as an abstract data structure which all different operations are to be performed on a stack. I always give example. All operations that we need is that kind of a push element onto the stack. The second, we should be able to pop the element from the stack. Third, probably I can say we can pick which is the topmost element of that. And if you at all need the fourth one, I can say that is it empty, is stack is empty or not empty. That's it. Now what is again the primary behavior that you're looking for from a stack? The primary behavior that I'm looking for a stack is last in first out. So I hardly bother whether the stack is internally implemented using array, whether the stack is internally implemented using linked list. Who cares? Or whether you are used tree or like graph, I don't bother. What all I bother is that the stack as an abstract data type we just talked about over here. So what functionality is being provided? What functionality is being provided? And on the parallel line, I'll take up one more example. Not all data structures that we will be discussing on a day one, but you go ahead. The another one, you can say that we can talk about a queue as an abstract data structure. Queue as an abstract data structure, you find that it comes with the same way. What is that? Push functionality, pop functionality, pick functionality, is empty functionality, obviously with the different intent. What is that? Here you look for first in, first out, isn't it? Yes, absolutely. So I'm saying that this is nothing but abstract data type. So while you implement, obviously you need to think of कि अगर मैं खुद का स्टैक का क्लास लिख रहा हूँ तो मुझको उसके अंदर कौन कौन से फंक्शनलिटीज देने हैं। अगर मैं खुद का क्यू का क्लास लिख रहा हूँ तो मुझको उसके अंदर कौन कौन से फंक्शनलिटीज देने हैं। डेफिनेटली आई नीड टू थिंक ऑन and definitely I need to implement it accordingly. But the minimal requirement, yes, we should be knowing in advance, and that is the reason we say that data structures are abstract data types. And that is the reason you will also find that the most common implementation, again I'm not saying that it cannot be done in other way around, but the most common implementation of all data structures are primarily done in an object oriented fashion. So you go to the C++, you go to the Java. So it is most common that people prefer making the data structure implementation in a OOP manner than in a procedure oriented manner. It's very common because the abstract data type, this concept closely resemble to the OOP paradigm, isn't it? So that was all about like a quick review, what data structures are, what are the like kind of rough classification, what do you mean by data structure as an abstract data type, as we will actually start working in the sense जब हम लोग let's say stack और queue पढ़ेंगे, we will talk about like what are the ADT operations, and then we will start implementing it. When we start discussing about linked list, we will again talk about the ADT operation, and then we will start discussing onto that. So every time you take up one and you start discussing it further. Now that is basically the idea. Then you continue further. Now we already seen what are different data structures. That is all right. But I told you that when I say that I want to organize the data into the memory, when I say that I want to process that particular data, and then I use a word saying that I'm looking for everything to be done efficiently. But the question is, what is definition of efficiently? What do you mean by efficiently? How do you say that whatever that you are doing is efficient? Because it is like a human nature that whenever you do something, you always believe that whatever you are done is correct, isn't it? So you come down to the like there is like a lab exam. There's a lab exam you have done something, and you always say that जो मैंने किया था वो सही है. हाँ, you might say that the question is wrong, but जो मैंने किया था वो सही है, because I always do correctly. People always have got a thought process. तो यहाँ पर ये कैसे possible होगा? How do I actually talk whether it is efficient, whether it is not efficient? Like for example, I'll take up some simple example which probably you can understand. Again, a bit different. When we start with the module like a database, there was story was different because database was like something entirely new to everyone. So like what exactly database is, so probably from there we need to start, and then we need to discuss from there step by step till advanced topic. But when it come down to the like module like data structure, we understand that I understand that it is a kind of a prerequisite of a course. So some basic data structures you already know, you already aware of, and forget you people recently you people learn Java, so you might have even revised some of the basic concepts. So obviously I will keep that in mind when I'm delivering this presentation. So see to it that you also keep it in mind and retrieve it as early as possible. That will be really great. So coming back to the point. So you say that, sir, I'm creating an array of 10 elements. So what is efficient? So my array is taking for 40 bytes is efficient, or is it taking 20 bytes is efficient, or is it taking 10 bytes is efficient? Now you people understand it very well that array may take 40 bytes, array may take 20 bytes, array may take 10 bytes. Array of 10 element, the same array of 10 elements may take the different size depending on. Can you just complete the statement? I said it may take different time. Yes, it depends on your data types. Absolutely. So somewhere someone is saying that कि I'm creating an array of integers. So 4 byte का integer होगा, it will take 40 bytes. अगर 2 byte का short variable होगा, it will take 20 bytes. अगर character variable होगा, probably it will take the 10 bytes itself. So what all the point that I want to make it over here is that it is very much dependent on a requirement. You cannot say that, sir, I created an array of 10 elements, so my array is efficient than probably your array, because your array is taking 20 bytes and my array is taking 40 bytes. The problem over is that you might be trying to solve a problem where the short variables are sufficient, and I might be solving such a problem where I need a kind of integer variables. So that is not really the measure that how many bytes it take to store. Number one. The secondly, not only about this, there is something, architecture specific stuff is also there. So sometimes you might have seen that, some architecture size of int is different and another architecture size of int is different. Like right now we are like, x86 platform, we find that size of int is 32-bit. But the same thing you do like a older 8086, or for that sake 80186 or 80286 machines, at that time size of integer was 2 byte. Or probably you go on like an embedded platform like AVR, size of int comes out to be 2 byte. So what I'm saying is that even though by saying you say that it is like an integer, कहने के लिए वो int है, लेकिन that again might have the architectural dependency. I hope you realize the problem, that you cannot always count the efficiency of storage based on based on how many bytes that you occupied. And the same is the problem with the time as well. Let's say that I always say that, like for example, a certain algorithm, let's say that XYZ algorithm running on my machine is taking let's say 10 millisecond. But probably another algorithm that you are running on your machine, the for doing similar thing, let's say one sorting algorithm I'm running on my machine, it is taking 10 millisecond. But the same sorting algorithm, probably you have developed some different sorting algorithm and it is taking 15 millisecond. So do you believe that the 10 millisecond is faster one? I repeat, one algorithm is running with the 10 millisecond time. The second algorithm for similar sort of data, similar amount of data, probably it is taking 15 millisecond. So can you say that 10 millisecond is efficient one? Do you believe that? Yes, you can say that. Oh, how come? Because what I'm saying is that the machine that I'm using is kind of Core i7 machine, and the other person, the machine that he is using, probably the Pentium machine. Is it possible? And now in this particular case, I hope now you visualize that. So on paper, or probably by looking at time, you can say that sir 10 millisecond is faster and 15 millisecond is slower. वो ठीक है, on paper you can say, but what about the architecture on which the execution is done? What about the like computer type that you are using? So like someone is using a machine of let's say 1.5 lakh, someone is using a machine of let's say 10,000 rupees. Again, it's not only architecture dependent, it is also even the machine configuration dependent. Whatever I was discussing right now, whether it is about space, whether it is about space, whether it was about time. This kind of analysis, you will refer it as this kind of analysis, you always efficiency का ये जो analysis है, this analysis you always say that exact analysis. This is exact analysis. And then you ask the question, so what do you mean by exact analysis? The exact analysis of a space, probably you can talk in terms of how many bytes that you are taking for executing certain algorithm or storing that kind of data. And the second one, where you talk about the time, machine time, or the number of CPU cycles, you can say millisecond or microsecond or something like that. So you're talking in that terms. This is referred as the exact analysis. But this exact analysis, most of the time it has been observed that it is useless. Why it is useless? The exact analysis is found to be useless. Why it is useless? Because the things will change from architecture to architecture. Things will change from machine configuration to machine configuration. तो सर कोई solution है? The solution is that exact analysis जहां पर काम नहीं करता, we always go for something called as a asymptotic analysis. Asymptotic analysis. Now where you always talk about, when you always talk about, now how many bytes, nahi, I'm saying that over here we will talk about, let's say, unit space. We will talk about the unit space required for the storage. We do not talk in terms of bytes. Or for that sake, asymptotic analysis for the time. So I'm talking about usually how many iterations in this is how many times the loop is getting repeated. I'm talking about asymptotic analysis. So we have got like a exact analysis or asymptotic analysis. So you need to understand that usually when it comes to data structure, we always discuss about the asymptotic analysis. We do not discuss about the exact analysis. Is one. So, sir, what basically asymptotic analysis is, how it goes, and etc. etc. Let us take a look at. The very first thing, yes, obviously we want to talk about is the space complexity first, and after that we will take a look at what is time complexity. So, what is space complexity? It is space complexity. I can say that it is a unit space required to store the data and the additional space required to process the data. So usually when it comes down to the space complexity, there are two components involved. Please make a note of that. The first component I say is the input space, and second thing is, let's say, auxiliary space. I'll give you example. I'll give you example. Suppose that you want to calculate the factorial. You want to calculate the factorial. A very simple, stupid example, I know. So you want to calculate the factorial. To calculate the factorial, what do you need? You need a number. Now you need a number. To store that number, you need some space. So that space you can say like an input space. But the second thing, to calculate the factorial, I guess you need some extra variables to occupy the result, some extra variable to go through the loops. So जब आप लोग कोई extra variable use करते हो, कि loop variable, a result variable, or something like that, I said that it is an auxiliary space. It is an auxiliary space. So we have got like an input space, and the extra variables that we might need during the processing, I call it as auxiliary space. So you call it as a space complexity. You continue further. You continue further. So what is different space complexity? Mechanisms are there. I can say that it's like a O1, ON, ON square. So what exactly O? How do we read it? I can simply say that it is something called as a order of. Technically, it is called as a big O notation, but I always say that it is, read it as like a order of. The order of either you say order of n, or you say order of n square, or sometimes you say order of 1. So what do you mean by order of 1? The order of 1 simply means it is a constant. It is not changing with respect to something. I'm hoping that factorial program you can imagine on yourself. And if you're imagining a factorial program by yourself, you can always say that अगर मैं normal loop लिख के अगर मैं factorial calculate कर रहा हूँ, then in that particular case, the what is input space is like one integer. So that space is required. Usually जब हम लोग space complexity की बात करते हैं, we are like more bothered about auxiliary space, the extra variables that we need. So don't you think that अगर मुझको 5 का फैक्टोरियल निकालना है, मुझको 10 का फैक्टोरियल निकालना है, या मुझको 10,000 का फैक्टोरियल निकालना है, आपको फैक्टोरियल चाहे जिस किसी नंबर का निकालना है, you will always find that the loop variable, you need one loop variable, you need one result variable, that's it. Now it is irrespective of कि फैक्टोरियल आप लोग छोटे नंबर का निकाल रहे हो, बड़े नंबर का निकाल रहे हो, बहुत बड़े नंबर का निकाल रहे हो, I would say that the extra space extra space that is required is going to be the constant. It is going to be the constant. So you say that in that particular case, your auxiliary space for the factorial is kind of O of 1. It is not changing. It is not changing with respect to the number whose factorial you want to calculate. But I'm very sure if you ever think of factorial using recursion, now factorial using recursion when you're doing, uh, definitely we will go ahead, we will learn recursion once again. At that time I will explain, but just for time being, you can just relate if you already know. So you might have heard that whenever you are trying to call a factorial of 4, a function activation record or stack frame is created for the factorial of 4, which is internally calling kind of factorial of 3, which is internally calling factorial of 2, which is calling like a factorial of 1, which is calling, let's say, factorial of 0. What is happening? The number for which you are trying to call the factorial, those many function calls are made. And if those many function calls are made, if those many function calls are made, with those function calls will take some space occupied onto the stack. Oh yes, it will take some space occupied onto the stack. I'm talking about that. So you go back. So in this particular case, the space complexity, the space required is probably proportional to n, as the more bigger number you are trying to calculate, the more function activation records need to be created on a stack. So जितना बड़ा number होगा, उतनी ज़्यादा जगह आपको stack के ऊपर लगने वाली है. I can say that in this particular case, that not really time, I should say that space is proportional to n. And if the space is proportional to n, we can say that it is of order of n. और फॉर दैट सेक आगे जाके हम लोग अलग से पढ़ने वाले मोस्ट कॉमन एग्जांपल, अ ग्राफ. You try to create a graph of, let's say, v vertices. To create a graph of v vertices, we say that we need to create a matrix. We need to create a matrix of v by v matrix. You are creating a matrix of v by v matrix, so you can say that the space is proportional to n, where let's say n, sorry, space is proportional to n square, where n is number of vertices. In that particular case, क्योंकि वो matrix है ना, a 2D array, 2D array, it's n by n array. So obviously the space required is of order of n square. So this is like pretty simple. What I'm trying to say that like a order of. So here you are not talking in terms of how many bytes. Are we talking in terms of bytes? No, not at all. We are not talking in terms of bytes, but we are talking in proportion to some factor, either the number whose factorial you want to calculate, or the number of vertices, or number of edges, or let's say height of a tree, or for that sake whatever it could be, correct, or number of elements in an array. So with respect to something, you are trying to tell the proportion, how much space it is going to occupy. So that is called a space complexity. But then you continue further, look at time complexity. The time complexity, where we say that the unit time required to complete any algorithm, we are not talking about how many millisecond or how many microsecond or how many nanoseconds are required, because those will change heavily depending on your computer, depending on configuration of your computer, depending on architecture of your computer. So I do not want to talk about that. So what exactly it is, it is usually you say that it is approximate measure of time required to complete any algorithm, wait for a minute, what is that, based on some factor, with respect to some factor. So whatever time that we are talking about, we are always saying that it is a time with respect to something, the time with respect to something. So with respect to this, with respect to that, whatever you said, but it is with respect to something. As I told you, it could be like how many elements in an array, It could be how many elements are there in linked list. It could be what is the height of a tree. It could be how many vertices and edges that you have got, whatever. So it depends on the data structure. It depends on the, or what values that you are trying to find out. But you need to find out the proportion कि कौन सी चीज, कौन सा फैक्टर ग्रो हो रहा है, तो करस्पॉन्डिंग उसका टाइम के ऊपर क्या असर पड़ेगा. दैट स्टडी is referred as a time complexity. If you are like absolute beginner, usual mistake that we always do is that we always consider that this many millisecond is better than these many milliseconds, but that is just a time. Here we are not at all finding how much time is there. Rather we are trying to find out कि time required will depend on which factor, and then in which proportion the time will change. Like I'll give you example. तो सर ये mainly किसके ऊपर decide होता है? अगेन कोई 100% और लाइक रिटर्न रूल नहीं है, बट वी कैन ऑलवेज से दैट द टाइम रिक्वायर्ड इज प्रोपोर्शनल टू द नंबर ऑफ इटरेशंस दैट आर कैरिड आउट. इटरेशंस, कितनी बार आपका लूप रिपीट हुआ, कितनी बार आपका लूप रिपीट हुआ है, उसके ऊपर डिपेंड करता है. एंड दैट इज व्हाई यू से दैट द टाइम कॉम्प्लेक्सिटी ऑफ एनी एल्गोरिथम डिपेंड्स ऑन, time complexity of any algorithm depends on the number of iterations in that algorithm. So number of iterations are more, you say that the time required is more. Number of iterations are less, you say that time required is less. It is that simple. So you just continue further. Like again the common time complexities and its general significance I'm trying to tell you. वैसे भी जब हम लोग थोड़ा आगे जाएंगे, जब हम लोग एल्गोरिथम लिखेंगे, लेट्स से बाइनरी सर्च लिखेंगे, लिनियर सर्च लिखेंगे, सिलेक्शन सॉर्ट लिखेंगे, बबल सॉर्ट लिखेंगे, तो हम लोग वापस से इसके ऊपर फिर से सोचेंगे कि ये कैसे करना है. बट ओवरव्यू और काइंड ऑफ रफ आइडिया आई वांट टू जस्ट गिव यू ओवर हियर. द टाइम कॉम्प्लेक्सिटी, द मोस्ट कॉमन टाइम कॉम्प्लेक्सिटीज जितने मैंने यहाँ पर लिस्ट किए, ट्रस्ट मी अपने पूरे मॉड्यूल में इसके अलावा कुछ और आप लोग नहीं देखने वाले हो. सो अल्टीमेटली एज यू प्रोग्रेस विद द मॉड्यूल, मॉड्यूल में जितने सारे टाइम कॉम्प्लेक्सिटीज हर एक एल्गोरिथम के आने वाले हैं, so almost all I have just taken up except few of graph because they are kind of combinations. The very first, a O of 1. What is O of 1? O of 1, I said that the time is a constant time. The time required is a constant time. It is not dependent on any factor, any factor. So whether you are searching in 10 elements, whether you are searching in 10,000 elements, when you say that the time is going to remain same, the time complexity is said to be O of 1. Okay, that is good. O of n, O of n, the time required is proportional to n. Now when I say time required is proportional to n, again you take an example of a factorial program itself. जब लोग factorial program लेते हो तो क्या होता है? In a factorial program, what happens? You write a loop for I is equal to 1, I is less than or equal to n, I plus plus, result is equal to result into I. But your loop is going to run how many times? Depends on a value of n. So if your value of n is 10, the loop is repeated 10 times. If value of n is let's say 1000, then it is going to repeat for 1000 times. And if the value of loop is let's say 1 million, it will repeat 1 million times. What exactly I want to say? I want to say that the bigger is the number, more is the time it will take. More is the time that it will take. So here it depends on the number whose factorial you want to calculate. And whenever you see that it is O of n, usually again मैं फिर से बता रहा हूँ, मैं कोई hard coded rules आपको नहीं बता रहा हूँ, but I'm just trying to tell you the general observations. These are the general observations. Usually that will program involves a single loop. So most of the cases you will find that अगर आपके प्रोग्राम में single loop है, then it will be like O of n. Okay, that is good. I'll just continue further. Then going ahead, it is O(n) square. What is O(n) square? You are saying that the time required is proportional to n square. So any example? A typical algorithm, selection sort, bubble sort, what is that? These sorting algorithms, they all will be coming like a O(n) square. O(n) square is a typical example. I would say that it is a nested loops. Nested loops in the sense I'm saying loops inside loops. And how many nested loops? I would say that two nested loops, one within another. You can say that it is O(n) square. जब हम लोग सिलेक्शन सॉर्ट बबल सॉर्ट का कैलकुलेशन मैं आपको बताऊंगा, आपको समझ में आ जाएगा. जब लूप के अंदर लूप होता है, मीनिंग आई एम सेइंग दैट इनर लूप के इटरेशंस, inner loop is repeated each time for the outer loop. So outer loop के हर एक iteration के लिए, outer loop के हर एक iteration के लिए inner loop के सारे iterations होते हैं. आउटर लूप के हर एक इटरेशन के लिए इनर लूप के सारे इटरेशंस होते हैं, तब हम लोग कहते हैं इट इज ओ एन स्क्वायर. Okay, that is good. Then what is O n cube? O n cube, that you can see it is where again it is a nested loops, but it is now loop within loop within loop. So there are three loops back to back. A three loops back to back, you can say that it is O n cube. So do you know any algorithm? Yes, I know the algorithm. That is the only reason I have written there. Warshall Floyd algorithm. ये बहुत time है. Probably on the last day we will talk about that. But Warshall Floyd algorithm is typically a graph algorithm. And the graph algorithm, yes, it will take three loops, I, source and destination. और ये तीन loops एक के नीचे एक जब रन होता है, the time complexity is like O n cube. Now you go ahead. Let's say O of log n. What is O of log n? You are saying that the time required is proportional to log. But again, you ask the question, how you can say that it is proportional to log? I'll give you some example. A typical example where the partitioning is involved. Your whole array, you are trying to array, not necessarily array. You talk about any example जहां पर division होता है, जहां पर डिवीजन होता है, तो जहां जहां पर डिवीजन होता है वहां वहां पर पार्टीशनिंग इज इन्वॉल्व. आई विल गिव यू सम सिंपल प्रोग्राम. राइट अ प्रोग्राम टू कन्वर्ट लाइक अ डेसिमल टू बाइनरी. अगर आपने कभी डेसिमल टू बाइनरी कन्वर्जन किया है यूजिंग नॉट यूजिंग बिटवाइज ऑपरेटर्स, यूजिंग काइंड ऑफ अ डिवीजन मेथड, व्हाट यू कॉल अ डबल डबल मेथड. I hope you must have heard of it. You take a number, you divide, you record the remainder. Again, whatever is the result, again you divide by 2, again you record the remainder, and again you divide by 2, again you record the remainder, and you go in like a reverse way. So वो जो कुछ भी आप लोग कैलकुलेट करते हो, यहाँ पर हम लोग क्या कर रहे हैं? Whatever number that we have got, we are dividing by 2, dividing by 2, divide by 2, divide by 2, and we are trying to reach to the zero. So जहां जहां पर हम लोग ऐसा करते हैं, so जहां जहां पर जिस किसी कोड में कहीं पर आपको पार्टीशनिंग दिखेगा, there are likely chances are that the log factor is involved. The log factor is involved. Yes, binary search is the best example where you can find that the log n you can see. Don't worry, binary search वैसे भी हम लोग आज ही पढ़ने वाले हैं, so you will be able to compare and you will be able to appreciate that as well. Going ahead, O n log n. What is n log n? I said that the time required is now proportional to n log n. Now, what is this? In this particular case, again, log n factor is talking about partitioning, but the partitioning is also repeated. It is not one-time partitioning. If it is like one-time partitioning, that is fine. Then you say log n. But if it is partitioning is done each time, then you go for n log n. And the again best example would be quick sort, merge sort, or kind of heap sort, where the time complexity comes out to be O of n log n. I'll take up one two problems. As I said that the algorithm की requirement ही है, अपने model की requirement ही है कि we should be able to think a little. We should be able to think a little. So I will just ask you for some problems. I'm not expecting that you people write a code. I'm very sure you must have written a code sometimes somewhere, and then recalling that, if you could tell me what could be the time complexity, that will be great. Like one, let's say for example, I'm just going ahead. I'm just going ahead. The first one, check if number is prime. Check if number is prime. I'm not looking for the efficient implementation. I'm looking for a normal implementation. No efficient implementation. I'm not looking for any kind of efficient implementation. Yes, the time complexity will be O of n. Why time complexity is O of n? Because reason is very simple. Typically, the loop that we write is something like this. For I is equal to 2, I is less than n, I plus plus. And inside that, we check if n mod by 2 is equal to 0, then we simply say that this is not prime. This is not prime. Otherwise we can say that it is prime. Something like this. Yes, such kind of simple implementation we might consider, isn't it? Yes, absolutely. So I'm saying that in this particular case, what is important? What is important? You take a look at, oh sorry, my mistake, not mod by, ये even number check करने का part है. Yes, I got it. It should be n mod by I. So आप लोग क्या कर रहे हो, 2 से लेके हर एक नंबर तक, A2 से लेके हर एक नंबर तक आप लोग डिवाइड करके देख रहे हो. If it is divisible till number minus 1, 2 to that number minus 1, anywhere you find it divisible, you say that it is not prime number. But if it is not divisible by any of that, then you say it is a prime number. Absolutely there. What is important over here is a loop. And this loop, number of iterations are dependent on, a number of iterations dependent on value of n. So as your n grows, the number of iteration grows in the same proportion. So I can say that the time complexity over here should be considered as O of n. I'll take up like one more example. One more example, let's say find all combinations of A, A, B, and C. So given three characters, I want to find out all possible combinations. Let's say ABC, ACB, or whatever. So what do you need? I guess typically you need to run 3 loops, isn't it? Yes, you need to write 3 loops. And if you are writing 3 loops, you always say that it could be then in this case ON cube. So I'm saying that it is 3 nested loops that you can use. And the 3 nested loops, it will say that time complexity should be ON cube. But I repeat, ऐसा कोई जरूरी नहीं है कि एक लूप दिखे तो O ऑफ n, 2 लूप दिखे तो ओ एन स्क्वायर, 3 लूप दिखे तो ओ एन क्यूब. इसको रूल मत बना लेना. सोचना, एक्चुअल नंबर ऑफ इटरेशंस, आर दे रियली चेंजिंग with respect to something, or they are going to remain same. So before you answer, before you come up with the conclusion कि इसका टाइम कॉम्प्लेक्सिटी यही होने वाला है, यहाँ पर अभी हम लोग क्या सोच रहे हैं सर, यहाँ पर आपने ओ एन क्यूब, यू आर सेइंग दैट because it is like taking 3 nested loops. Yes, A B C आप लोग कह तो रहे हो, but as I said that, let's say for example A B C D, अगर आपको 4 निकालना है then probably there will be 4 nested loops. अगर आपको 5 का निकालना है there will be a 5 nested loop. But as long as you are changing, सर मुझको ABC नहीं करना है, मुझको XYZ करना है, सर मुझको XYZ नहीं करना है, मुझको PQR करना है. Now you will find that it is not really changing with respect to, it is not changing with respect to how, which characters that you're using. It is changing how many characters are there. You please keep this in mind. So before you answer, you need to always say, okay, what exactly is it really changing? आपने cross check करना चाहिए. I'll take a one more example and then we will move on to the actual work. And I want you people to think a little. I want you people to think around this and then answer me, because this is a bit tricky. This is a bit tricky. So print table of n. A table मतलब 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 tens are 20. This is what you call it as a table. So given number का table print करना है. So what do you believe? What is the time complexity? मैंने कहा सोच के बताना जवाब. Yes, that is good. Like people are thinking, and many of them are thinking. So that is really good sign. I say that time complexity will be O of 1. Now you ask the question, sir, O of 1 कैसे? Loop तो है ना? अरे loop है, लेकिन is it dependent on any factor? You always know that your loop will be something like this. For I is equal to 1, I is less than or equal to 10, I plus plus, I plus plus, and simply you want to print number into I. This is what all you're doing. So आपका n चाहे 1 हो, आपका n चाहे 100 हो, चाहे आपका n 1000 हो, is it going to make a change into the number of iterations? Not really. And if it is not going to make a change in the number of iteration, you should not blindly just say that the time complexity is, let's say, O of n. अगर आप लोग blindly कह रहे हो, then it is very dangerous. I hope you got the point. And this is something that I'm trying to tell you always कि time complexity मैंने आपको rough ideas दिए, मैंने आपको examples दिए. What is more important is that you should always, once you can just guess something, no doubt on that, but after you guess, you should at least think logically, क्या सचमुच एन चेंज होने से ये बदलने वाला है? अगर बदलने वाला है देन इट इज ओके, अगर नहीं बदलने वाला है इसका मतलब यू नीड टू रीथिंक ऑन इट, राइट? सो गोइंग अहेड, तो सर ये जो आपने यूज किया, यू से दैट इट इज ऑर्डर ऑफ, or you call it as let's say big O note, sorry, order of, or you call it let's say big O notation. So do you believe that that is the only notation available or not really? Huh, so is it only available or not really? So you find that big O is kind of one notation, but apart from that, there is another notation called as omega notation, and there's also notation called as let's say theta notation. So what these notations are all about and why the multiple notations are there? To be frank, there's a lot of mathematical jargon behind it, but to keep it simple, the big O notation talks about the upper bound, or you can say that how much time maximum it will take to run this algorithm. One talks about lower bound, how much is like a minimum time that it will take to run the algorithm, and where theta, where you try to be bit more precise, what is the maximum and what is the minimum time, correct? So upper bound, you talk about the maximum, अगर आप लोग time complexity की बात कर रहे हो, then I can say that like a maximum time, maximum running time. This one